So, right, let's get going. Okay, the first thing we want to do is to determine the climatological mean of sea surface temperature of the warmest month in the regions. In order to do that, you follow the link in the instructions. Okay, so because we will be using NOAA optimum interpolation SST distributions. Okay, and there's a link in the instructions. So you click on that link, and I show you the link. So if you click on the link, you come to this web page. Okay, and see the NOAA optimum interpolation, sea surface temperature, and you can learn about it, read the instruction. You can scroll down. Okay, it gives you information. Yeah. All right, description. There are some reference papers. Okay, for more information, there are some links. All right. Okay, there's also a link to plots. Okay, create plots. You see here, this, create plots, and this is where you just click on that little plot. Okay, and if you do that, you come to different options of what you can use. Okay, indeed, you could download the data. Okay, but you need to know how to work with this data. If you want to use the original data, they come in a format called NetCDF, and you need to have programs that can read these files, and then you can do all sorts of analysis with it. We're not going to do that. Okay, so now there are different options, and you can see that there are monthly long-term mean. Okay, this is what we're after. The January mean over a long period of time, and the first one is 1961 to 1990. The second one is from 1981 to 2010, and this is what we want to use. Okay, I click on that again. Click on the graph. Here we go. All right, and we come to another page. Okay, so now you can, I'm just try to make it a little bit smaller. Okay, make it a little bit smaller. And again, lots of information. And if you just go down, if you just scroll down and you just press create plot, then you get a plot, and you can see you get a global plot. Sea surface temperature, you can see contour lines, you can see some numbers. Okay, so all right, so now let's go back and we refine it a little bit, make it a little bit better. Okay, and I just need to find a little bit of information. Okay, all right, go back, just the back button, go back, and we refine it a little bit. So the first thing that you should do is you specify the dimensions. Okay, latitude and longitude ranges. Here you can see you can change the latitude and longitude. And let's see, what did we use? Was that something like 140 to 160 east? I might get it wrong, but it's always okay if you make mistakes. And say 30 south to 10 south. Okay, so you look up in a map the region that you want to show. Yeah. So you go down a little bit, you can see which month you want to do. January, February. Let's choose February. Okay, I use February. From February to February. So these ones you have to do it twice. Monthly average data. Okay, so let's see how it looks like now. Can always go back if there's a mistake, create plot, and you can see a distribution. Okay, and I can check and double check, and this is definitely the Great Barrier Reef. Yeah, thumbs up, thumbs up. And you can see again the temperature distribution, 29. Okay, contours, and you can see that the contour interval is 0.25. All right, so you can even refine it a little bit more because I don't like black backgrounds. So if you print it out, it uses up lots of ink. So just go back. Okay, and you can see that there's the option of plot on white background. I do this, plot on white background. Then you can also specify the contour range. And let's just do something like, let's see what happens if I do 20 to 30 degrees. And if I want to do a contour interval of 0.1 degree, I have a little bit finer resolution, and just again create the plot. Okay, so you can see that the plot looks a little bit neater, a little bit better. Okay, but however, the contour interval hasn't changed. You can see it's 0.25 still here, and there's even a note at the top. Let me just try to go back and see note. Your selections result in 100 contour levels. It's just too many, so you must have less than 32 intervals, and you can change that a little. Okay, I'm going back again. Back button. And how do I change it? Maybe I go from 25 and I do a contour interval of 0.2. And this is something you need to do. Just play around. Okay, play around. Here we get temperature distribution. And let me try to have a look. This one is 0.1 of a degree, isn't it? All right. So, all right. So, what can you now do with it? Sorry. What can you now do with it? What you need to do, and I get it a little bit bigger, plus, okay, get it a little bit bigger. You need to read off the temperature value. You can look at this. Okay, and this is 0.2 contour interval. Now you can see it a little bit. So now what we decided to do is we look at 16 degrees south. So what's the temperature at 16 degrees south? I go here, and it's sort of 29, but a little bit more, maybe 29.05. So you have to visually interpolate. You just write down this value, and that's what you use, okay? The other region is 22 degrees south. You go here, 22 degrees south. You follow, and you near the coast, and there the temperature is, this is 28.4. The green line is 28.2. Okay, and you have 0.1 less. Okay, so this is how you estimate the temperature. So play around a little bit with this, and this is how you can read now your read of your temperature. The climatological mean temperatures. Hooray! Okay, you play around with that, and you can do it at home, but if you're still a little bit confused, just come to your CML session, and the demonstrator can help you with it. Okay? All right.